Assalamualaikum warahmatullahi wabarakatuh to our madam and whoever is watching this video. And the topic for this video is the application of differentiation. Now, before we start, the name of the group is Group 1 since we don't actually know what to put as for the group name. So we just put it Group 1. It's easy as that. Now, for the group members, the first one is me, Muhammad Irfan Muhammad Sukri, and the second one is Ahmad Daniel bin Omar. Say hi.
Assalamualaikum, madam.
Wah, all right. All right. And the third one is Muhammad Hakim bin Abdul Aziz. Say Assalamualaikum, brother.
Assalamualaikum, madam. Hope you eat in the me.
All right. Let's continue with what is differentiation. Differentiation is or in other words, derivative is of a function of a variable measures of the sensitivity to change of the function value with respect to a change in its argument. Now, the derivative is the fundamental of the calculus and also the fundamental of engineering. So, whoever takes the engineering course must master this differentiation because it's part of the calculus and it is the fundamental of calculus. Without this, we can't say that we are an engineer. So, what is the application and what is the use of differentiation? Now, for this video, we'll be only talk about one application, which is maximum and minimum. So, maximum and minimum is useful stuff because we can calculate the cost, the strength, the amount of material used in the building, profit and loss, and etc. There's a lot of use of it. So in the real world, it is really function because we can actually save something, such as money by using differentiation. Derivative are met in many engineering and science problems, especially when modeling behavior of moving objects. Now, let's continue with the use. Well, just like I said, it is used for many applications, but since in this video we'll be only talking about minimum and maximum. So, let's continue with a question. Now, for this one, Hakim will be continue this part. Now, Hakim, I'll pass the baton to you.
Thank you so much, Irfan, for your explanation. Now we will move on to the question. Question is the Winchester Bottling Company wants to make liter-sized soda cans. They want to make a cylindrical cans that will hold 1 liter, 1,000 cubic centimeters of soda. Being ecology and economy minded, the company wants to use a minimum amount of material. What dimension will enable the use of minimum material? Now, before we move on to the question, we need to know the main objective for this question. Okay, please to the next slide. Fine. Thank you. The main objective for this question is the dimension that can be used to minimize the material, and we need to find the value of the dimension. Okay. We now are going to move to the equation, and I will pass it to Daniel. Please continue, Daniel.
Okay. Once again, Assalamualaikum and hi, madam. I will tell you how to solve the problem here. In this question, we have the Winchester Bottling Company that want to make a cylindrical cans. And from the cylindrical cans, we can have the formula for it. And next is 1,000 cubic centimeter. That is the next clue. And also, they want minimum. They want to reduce the cost for the material. Next, we move to solve the question, the problem. And from the problem, we have the formula, which is surface area is equal to the 2 pi r squared plus 2 pi r h. A is the surface area, and then the 1000 cubic centimeter, which is the volume for it, and the formula for it is pi r squared h. And we have the two unknown, which is two variable. We can solve we if we have two unknowns. So we have to make it to one unknown, which we can make it using h, which h is equal to the 1000 over pi r squared. So next we substitute the h. Next, please. So next we substitute the h into the formula, which we get a is equal to 2 pi r squared plus 2 pi r in the bracket 1000 over pi r squared. And next we simplify it. We get 2 pi r squared plus 2000 over r. Uh, from from it we differentiate a, and we get next and next. Okay, and we get the 4 pi r minus 2000 over r squared. So for the next, we have to make the first derivative into equal to 0. And next, 4 pi r cubic minus 2000 over r squared. You will uh, in this we simplify it, and we make the for the two number the same nominator, so you can simplify it easier. So and then we get the answer, which is root 3 500 over pi, which is 5.419 centimeter. And then don't forget about the first equation that we get, which is h is equal to 1000 over pi r squared, and we substitute r 5.419 into it, and then we get the answer, which is 10.8 centimeter. And for us to confirm the minimum or maximum value for the r, let us take a look at the second derivative test. For this, the second derivative test, I will give it to Akim. Thank you, Akim.
Okay, thank you so much, Daniel, for your explanation. Now we will move on to the second derivative test. As Daniel said, second derivative test is used to determine whether the value is maximum or minimum. So we just take the first differentiate from the first step and differentiate it again from 4 pi r minus 2000 over r squared to 4 pi minus 2000 over r power of 3. And we just take the r, that the value of r, which is 5.419, in the equation that we just give a shape, and we will get 37.702, which is larger than 0, that make the r is the minimum value. Now we move on to conclusion. So the conclusion for this question is we can minimize, the dimension that we can minimize is r and h, which is r is equal to 5.419 cm and h is equal to 10.8, and that's the end for this question. Thank you so much, madam, for listening to our presentation. We really hope you have a great day and in a great health. Uh, that's all for us. Goodbye, madam.
Bye,
Thank you,
madam.
madam.
Bye, then.
Bye.